All right. Amazing. Great. Well, welcome everybody, especially to our students in the audience today. It's really great to have you here, and I think you are going to learn a lot. I'm already learning just from looking at the slides, and I haven't even heard the talk yet, which is exciting. So I want to introduce our speaker for today, and that is Kaitlin Noyes, and she is an educator and a scientist, and lots of good things to share with you about a recent trip to sea that she took. So, Kaitlin, I'm going to turn it over to you, and we can go from there.
Sounds great. Well, I am so excited to join all of you. I'm going to be in the corner of your screen because I'm going to be sharing lots of media from our recent expedition in the Pacific. It was my very first time to this special ecosystem, which is the hydrothermal vents, and my very first time diving in a submersible. And so I'm going to be sharing a little bit of insight as to what it was like to be down there, and just share a little bit about how these ecosystems exist in the first place, because they're really quite special. Bear with me. I'm joining you from the island of Bermuda. And so if there is a slight lag in the video, it's because I'm joining you from the middle of the Atlantic Ocean. As Meg mentioned, as Dr. Marrero mentioned, my name is Kaitlin Noyes. I'm the Director of Education here at the Bermuda Institute of Ocean Sciences, and this was my very first expedition to the deep. Today I'm going to share with you some media, and then we're going to pause because I really want to hear from you and questions that you have about hydrothermal vents or some of the creatures that we saw in the deep sea. So first and foremost, where on earth was our ship and where were we going and why? And so we were aboard the RV Atlantis, which is a ship owned by the US Navy, and it's operated by Woods Hole Oceanographic. And we were at an area of an edge of a tectonic plate. Now, what on earth, Kaitlin, do you mean by a tectonic plate? You can kind of see these black lines here outlining these puzzle pieces. And I like to think of tectonic plates as these puzzle pieces of rock that are moving around on the liquid mantle. And you can kind of see some red arrows in some of those locations where there's boundaries between these plates. And so these guys can be doing lots of things. They can be going under each other, they can be rubbing against each other, they can be moving apart from each other. And we were at the western edge of Earth's very tiniest plate, which is right here in the Pacific called the Juan de Fuca plate. We were at the western edge because we wanted to be in a place where the plates were moving away from each other. So this is a divergent boundary. And what on earth does that mean? It means that at the edge of this plate boundary, we have a lot of volcanic activity. And so new Earth under the ocean, or new crust, I should say, is being created in these areas, and they're growing. And so the Pacific plate is moving away from the Juan de Fuca plate on its western boundary. We mainly were going there because we wanted to investigate these hydrothermal vent fields, which tend to be associated highly with these divergent plate boundaries. And so here we were about 250 kilometers west of Canada, Vancouver Island to be exact. And so, what on earth is a hydrothermal vent? In its very simplest form, it is a crack or an opening in the ocean floor in which heated mineral rich water is emerging. So, if I drained the ocean in this area, you would get something like this drip castle, this 3D structure that we're going to talk a little bit about how it forms in these places. But just to give you an idea, we were right here on the Endeavour segment, right here, where we spent about 21 days. And we took a submersible, 9 different dives to a couple of the different vent systems that are there. So I mentioned that these vent systems are associated highly with divergent boundaries where you have a lot of heat moving around. And so in these areas where the two plates are diverging or moving away from each other, you have lots of volcanic activity, lots of movement of magma. And what happens is that it causes cracks in the Earth's crust. And so just to give you an idea of the sheer scale of these, I had a digital camera when I was down in Alvin. My window is at about 7 inches across, about 18 centimeters. It's quite small. But then when you look out the portal, these structures are huge. This was Hulk. It was a chimney that was about 20 meters. So imagine like looking up at a 7-story building of these structures that are formed there. The largest structure we found, largest structure that we explored, I should say, because it's already been known, was Godzilla. And Godzilla was 45 meters tall. And so let's talk a little bit just briefly about how these hydrothermal vents form and why they're there in the first place. And so we talked a little bit about this being a plate boundary. So here are these two plates moving away from each other. Volcanic activity is creating new Earth crust. It's causing cracks in the Earth's crust, and that icy cold water, which is almost cold enough to freeze, can percolate on down. When it hits the magma, it's under intense heat and intense pressure, and it's like an underwater geyser that rushes to the surface. When that hot water, as it picks up a lot of those minerals, it hits the icy cold seawater, and it does something called precipitate. And it makes these mineral like drip castles made of different sulfides that are really quite fragile. The heat source can shift, and hydrothermal vents can go extinct in some places and then pop up in others. And in just under a year, these systems can be teeming with an entire vent ecosystem that is not based on any photosynthesis whatsoever. So we'll talk a little bit about how. But our scientists were really interested in collecting this fluid, hydrothermal vent fluid. And so we're going to be talking a little bit about why they wanted to collect this fluid and how they were able to do it. And please do, if you do have questions, please go ahead and put them in the chat. Dr. Marrero is monitoring that for me so that I can answer questions along the way. So I said that we were sampling this fluid. So basically, we're looking for this superheated fluid coming out of the Earth's crust associated with these hydrothermal vents. And we were sampling this fluid in a couple of different ways. And so here you can see some 4K video. There are GoPros that are mounted to our submersible in special housings that is allowing us to have a look at these black smokers. Now, these black smokers are about 327 degrees Celsius. That's 3 times the temperature of boiling water, a little bit over. And we did not expect to find any life in these fluids, but we were sampling them just the same to get a better idea of their chemistry. The hottest microbe or bacteria or virus or archaea that's known lives at hydrothermal vents at about 122 degrees Celsius. So these black smokers would be too hot for them to survive. What we're really looking for is also what's called diffuse flow. And I'm going to show you a little bit of an image of what that is. But you're starting to see these red guys here popping up. And this is what our scientists were really interested in. And these are our tube worm gardens. So I wanted to show you just a little bit so you believe me of how hot this water is. And so you can see some of this bubbling water here. This is what we would call diffuse flow. This is less than 100 degrees C, and we're starting to see a ton of marine life that is able to survive and thrive in these areas. Of course, they're not using photosynthesis. They are highly dependent on bacteria and viruses and archaea that are helping them fix chemicals like hydrogen sulfide to chemosynthesize. And we'll talk a little bit more about that in a bit. But what our scientists were especially interested in is these tube worm gardens. These were the main part of why we were floating around Endeavour for 20 days. You can see these beautiful 3D structures that these tube worms make. This is an endemic tube worm to Endeavour, which means it's found nowhere else on Earth. And these tube worms can be up to over a meter long. One of the things that you can see is they have these incredible gills at the top. They're really concentrated in hemoglobin. They have no mouth and no gut. They are completely dependent on chemosynthetic bacteria that live inside a special organ inside their body that helps them take toxic chemicals coming from these hydrothermal vents, like hydrogen sulfide, methane, hydrogen gas, and use that to create energy and use that as the base of this food chain here at the hydrothermal vent ecosystem to provide food and mats for a lot of these other organisms to eat. So we were particularly interested in collecting the fluid from these tube worm gardens. Now, I know many of you probably are familiar with beautiful things like oyster reefs and coral reefs. We think of these as ecosystem engineers, right? They make a skeleton or they make a shell that makes a 3D space. We were looking for something very similar in the deep sea. And there's no better ecosystem engineer. Well, limpets are pretty good, but there's no better engineer probably than the tube worm at these ecosystems. And so what they do is they create this garden that they can trap some of that hydrothermal vent fluid. And so the theory of why we were going to look at these areas is we wanted to look at microbes. So when we talk about microbes, this is a large group of things like archaea, bacteria, viruses that are all able to donate electrons to the seawater surrounding, which is electron hungry. And this helps in this whole chemosynthetic pathway in an area that is actually really, really low in oxygen. So it's a really interesting place for us to look at these microbes. So I'm going to go ahead and play the rest of that video here. And so we had specialized equipment that was allowing us to collect fluid from the base of these tube worms all the way to the top. And we are seeing, and what we've seen from the early results and what we expected to see is this actual microbial community completely shifts as you go from 100% hydrothermal vent fluid at the very base of the garden to when, as it's mixing with seawater slightly towards the top of the garden itself. And so we were sampling for these microbes, and I've already talked a little bit about this. Sorry that my head is blocking chemosynthesis, but this chemosynthesis where these organisms, these bacteria, are being able to fix things like hydrogen sulfide to make glucose, which is what you and I are surviving on. Obviously, our primary producers on land, our plants are all producing glucose via photosynthesis. And things like algae in our ocean are using photosynthesis, but obviously we have no sunlight down there. It's very cold, it's very dark, it's very high pressure. And so these whole vent ecosystem is highly dependent on these microbes to produce to take these chemicals and fix it to allow for sugar to be made for other organisms. So just to give you an example, this is a photo from one of our vent systems where you can see this bright white microbial mat. This is what all of your other things like other snails and limpets are going to be feeding on. And we were sampling these areas versus sampling the tube worm gardens to look at how the microbial community changes in these areas. Okay. So how on earth did we actually get these samples? We know that it's pretty hot water. And so how are we going to be able to sample these fluid systems? So the first piece of equipment that we use that I think is pretty cool, it is an isobaric gas tight sampler. Now, what on earth does it do, Kaitlin, and why is it important? This is really cool because it has first an inlet snorkel here at the bottom that is made of titanium. Titanium is heat resistant, and so it allows us to get right into the hydrothermal vent fluid. The second thing that's really cool about this instrument is it allows us to actually collect that fluid at pressure. So at the surface, we're under 1 atmosphere of pressure, you and I right now, but where the submersible was, we were about 2,000 meters. So we were 201 times the pressure at the surface. And this allows us to collect those samples using a background helium gas to actually allow us to capture this fluid and the microbes in it at pressure. And this is an instrument that hasn't been used like this for this particular gradient for looking at how these tube worms survive, how these microbes survive in these tube worm gardens. And so let me just show you a little bit about how it's used. So you can see here Alvin using its manipulator to pick up what's called the isobaric gas tight sampler and put it right into the microbial mat to collect the fluid. And it's collecting that at 201 atmospheres of pressure and maintaining that pressure as it brings it to the surface. Here's us using another gas tight sampler to actually collect hydrothermal vent fluid from a black smoker. So just one piece of equipment that we were using on the research, on the HOV Alvin. The other piece is we also wanted to look at the microbial slime on the tube worm itself. And so we had permission to collect some of the tube worms using a bio box. And so I'm just going to show you how Alvin uses that manipulator here. It has this really cool wrist-like motion that the manipulator on Alvin can use. The pilot has its own inside the sphere that it can use to rotate the wrist joint around and collect these tube worms to put inside the bio box. The bio box is pretty simple, but it is spring loaded. And so it uses this yellow rope to open and close the box so that once the manipulator puts the tube worm grab inside, then it can close the box with seawater and bring the sample to the surface. You can see it just a slightly better vantage point here with Alvin using that wrist to very delicately open that bio box, nudge it open, and then it will move on to collect those samples. So just two pieces of equipment that were being used in the front of Alvin's basket where all of our scientific equipment is operated. Okay, and this is Liz taking those, at this point, fairly stinky tube worms and extracting that microbial slime for us to use more DNA-based tools to figure out who's there in that slime. Okay. So another cool piece, obviously we were down there, we did 9 dives. Each dive is roughly about 9 hours. And so we were spent over 50 hours of actual time on the bottom because it takes quite a while to get in and down and back up again, which we'll talk about in a second. But we did find a lot of other cool creatures on our cruise that I wanted to share with you. And so the main creatures that we were out there sampling were these tube worms, these Regia. And so you're going to see a couple of different gardens that we sampled on the cruise. Here's another garden near a black smoker and another smaller, skinnier tube, same species. Based on the heat, they look differently, which is, I think, and then we also were interested in looking at some other worms, and this is an example of a palm worm. These guys have these crazy like hairs that are heat resistant, and they also live by ingesting some of the microbial mats that live around it. Deep sea limpets are also an amazing ecosystem engineer. You can see thousands of these little white guys all stacked on top of each other. 4 different species of brittle star. You can see them using their arms and feeding on detritus and things like big sponges. And then my favorite, but not a lot of my students have liked these are sea spiders. You can see here them crawling around on the vent. And the most common fish we found on the cruise was the zoarcid fish. It is the vent fish. It's an ambush predator, and it uses a lot of the spaces around the tube worms to hunt. These guys are quite small, probably only 2-3 inches, and they are called squat lobsters. And you can see all of the white kind of dots there. They're closely related to things like hermit crabs. A much larger crab that we found on every single cruise was the Pacific spider crab. It was also the most interactive, spending a lot of time exploring our scientific equipment. It was about roughly 1 meter or 3 feet across. And these guys, you can see they almost use their tripod-like legs, which would really help them in terms of getting around hot areas. The other fish that we found on at least 2 of the dives was the Pacific flatnose. Again, you could see the large eye that it has. And the Pacific white skate was pretty common. A nursery ground has just been found fairly close to where we were. These guys lay yellow mermaid's purses around the geothermal vents. Last but not least, in disguise, you would imagine anything that was red would be using it as its superpower because it would appear black at depth. We obviously have our LED lights on it, but this is virtually invisible to creatures at depth because all that red light has been lost. So just some really cool creatures that we found on the cruise, which I'm happy to answer more about any of them. My last part of the talk is really talking about what it's like to dive in Alvin and what it looks like from the inside and what happens when you're even getting ready to get into a submersible. So first, this is the back deck of the ship that we launched from, and it's just to give you a size perspective of Alvin. It is roughly the size of a small SUV, and it weighs about 45,000 pounds. And just to give you a little bit of an idea of kind of the history of Alvin, this, as of 2021, this submersible can reach 6,500 meters. So it can explore about 99% of our ocean. And that's a recent development. It's only in 2021 that it's now able to go that deep. And it has carried over 3,000 scientists down to the depths, including completing over 5,000 dives. It has two 200-pound manipulators for collection within its basket. And some of the most famous Alvin dives are the discovery of hydrothermal vents in the 1970s, and later the discovery of the Titanic wreck in 1986 are some of its most famous missions. It is a pretty small 8-foot titanium sphere for a pilot and 2 observers. And so we're going to talk a little bit about what you kind of need to prepare for and what you're getting ready for as you're getting into the submersible on dive day. So I just want to give you one last perspective just so you could see it from another angle. So we dropped down a camera on, I think it was our 5th day, so that you could see Alvin from a different perspective. And so here in the front, you can see the science basket. It is only 4 feet by 4 feet, and everything that we need for the dive in terms of sample collection is all mounted to that basket. You can see the 2 titanium manipulators that are going to be able to grab all of our instrumentation, help us with our sensors. And then Alvin has 6 thrusters, as well as you can see these 3 viewports. The middle one, you can see Bruce sticking his head out, the pilot. And we have one on either side as well for the starboard and port observers. This top part, the red part, is called the sail. And it is flooded during the dive. And so there is a large hatch in between those 2 sections. And we'll talk about why it gets flooded in a little bit. Okay, and this is just a better picture of the basket. So you can see, of course, we did have a visitor to the basket this particular day, but you could see almost everything has a valve that Alvin has the ability to grab a T, so it can either turn something or be able to very easily pick it up. But it also just gives you a little bit of perspective that we're not working with that much area. And so you can see we're quite close to each other inside the sphere. It can fit 3 people. The pilot is forward facing. They actually lean down on their joysticks. And the port and starboard observer are sitting obviously on either side. Right behind us is our entire life support system. And we can control the cameras. We can control at least 2 of the 8 cameras that are on Alvin. And so all the footage that you have been seeing is collected from these dives that we were on from GoPros that are just mounted in very specialized housings. So you can see the actual living part of Alvin is quite small in comparison to the whole rest of the vehicle. And of course, I did mention it's 45,000 pounds, but once we've got to the bottom, this setup is virtually weightless because it becomes neutrally buoyant. So how on earth do you get into this thing and what happens? So this is me on dive day getting into the sail. The sail is really the connection point for communication for the snorkelers. And I'll show you some of the snorkelers and how they help Alvin get in and out of the water. But I did take just a picture of the hatch so that you can see me going down. The dive itself was about 8.5 hours. And so you are down there for quite a while. And so you want to be ready to get in the sphere for a long day. You can see there's about 9 steps to get down the ladder. And this is the hatch. You can see these are actually somebody's feet. And this is the hatch that gets completely sealed. So a lot of people have asked me about the pressure. Once this hatch is sealed, it's sealed within that titanium sphere at 1 atmosphere of pressure as if you're on the surface. There's oxygen running inside the sphere, and it's taking the CO2 from our exhale and scrubbing it out so that there are sensors inside that are maintaining both the pressure as well as the air composition inside so that obviously the pilot and the 2 observers can breathe properly. And I just took a little snapshot of outside the portal just as we're getting ready to be lifted in, because this is the safe boat. The safe boat is going to be the one helping to guide Alvin and communicate with the ship that it is ready to dive. So I do think, oh yeah, last question is there a bathroom on the sub for those 9 hours? And the answer is no. But there is these lovely urinal bottles that you do take down with you. The motto in the Alvin Club is pee before you go. But they do have these and adapters, and there have, obviously there have been people who needed to go to the bathroom even on our cruise. But my team, it didn't in particular. But it is a question that I get asked. If you're going to be down there for 9 hours, what happens if you have to go to the bathroom? So these are what the bottles look like. Okay. What are you allowed to take with you? And so one of the pieces of the puzzle is that you have to wear 100% natural fibers, so cotton or wool, and you get a pillowcase. And the pillowcase is really for ease of checking, ease of dropping it down into the sphere. And I brought a sweater because it gets quite cool down there, a hat, gloves, a dairy milk. I brought chocolate, a you can wear your watch, you can bring snacks, and your notebook and your pencil. Um, it is quite intense experience as you're getting lifted off and you realize that you're about to head down to 2000 meters. And so I did take a video just to kind of share with you. Hopefully you feel the tension in it because it was quite tense in those first 500 meters that you're going down. So I just wanted to give you an idea. This is a photo that I took as soon as I sat down for the dive. And this gives us our GPS coordinates. Now, a great question is like, of course, once we're going down beneath the waves, we no longer have connection to satellite. And so how are we then navigating between these GPS locations? I had the youngest ever pilot. Kaitlin is 28 years old. And this was the first time that they had ever gone to this location. And so they were navigating with these locations. And there was a few points of our dive that we did get a little bit off course. And so we were communicating with the ship at all times using sound. So we have a hydrophone that we can call up to the ship and talk to some of the other pilots, but also they can use sound in relation to where Alvin is to the ship to help us navigate those GPS points, even though the GPS isn't working underwater. Um, I just wanted to also show you in terms of these buttons here. These are all your red emergency dump valves, and this button here is your red emergency power. So in an emergency, you can actually dump both titanium manipulators, the whole basket, and your batteries. And so the fastest you could probably come up from, just for safety reasons, from 2000 meters would be in about 40 minutes. And so this would allow you to come up a little bit faster. It took us roughly about an hour to get down and roughly about 55 minutes to return to the surface. So you can see this is the cord here that ties to the hydrophone. And these are the snorkelers that will be helping guide Alvin into the water and communicating with the ship from the sail, from the red sail before the safe boat picks them up. And you can see this is one of the safety snorkelers. Inside that hatch, she has a comm setup very similar to my headset. It's waterproof. And she can communicate with the ship and also communicate down below with the pilot before they get the all clear that they're ready to launch on the dive. So I played that so you could actually hear that echo. I don't know if it came through. I hope it did, but if the echo came through, that's actually the ship talking to us. So it sounds like it's going through a megaphone, like whoa. But just to give you an idea of what that hydrophone sounds like. But I hope also kind of the mood of the red light also a little bit communicates with you kind of the tension as we're starting to make our way down to 1000 meters. At about 200 meters, we've completely lost all light and we start to see bright bioluminescence. It's like being in a bioluminescent snow globe to about 1000 meters. I tried to take a video for you on my little digital camera that they gave me, but you can't actually capture the bioluminescence out of the window, which was a bit of a bummer. But then as soon as you're getting ready to get to the bottom, the pilot will turn on the LED light.
Oh, that wire is in the camera. I'll fix that later.
And I was just stopping to talking just because I wanted you to hear that. That is like a hummingbird sound almost, because that is actually how nimble this 45,000-pound SUV actually is. It acts like a little hummingbird with its 5 thrusters positioning around, because once it's dumped its weight on the bottom, it's dumped about 400 pounds. It's going to become neutrally buoyant, that it can kind of hummingbird around these gigantic event-like structures. So this is me. We've now made it to the bottom. It's quite cold. We've all put on our sweaters, and I'm holding the iPad. And the main job of the observer is you record everything, every sample you take, every depth marker, anything that goes wrong, any cool creatures that you see, all gets logged on your tablet and is part of your dive report at the end. So I thought to kind of start to close out the talk, because I want to leave a lot of time for your questions too, is to just walk you through the dive. So we visited 4 hydrothermal vents on dive 9, and I just wanted to kind of walk you through a feel of what that looks like in about 3 minutes. So it's a time lapse. So know that the submersible is moving quite fast through this experience. So we're rolling out the track. All 3 of us are getting the laptops ready inside the sphere. And we are getting in, and once we have popped in, we've said goodbye to the lifeboat. We have about maybe 8 minutes till we've completely lost all light. And at this stage, we might turn on the LED lights to just practice using some of our manipulators and things like that. But at that point, we're conserving battery. And so we conserve battery right until about 100 meters from the bottom. And so you can see Kaitlin just turned on just to check the manipulators. And so at this point, we are about 100 meters from the bottom. Now we've hit bottom, and the observers helped the pilot to actually see what's on either side, because it's actually really hard because you have no peripheral vision in the submersible. So you can see we're flying now to our first location. You can see the marker 5 there. And the basket only needs about 1 foot by 1 foot to kind of steady itself on the side of the vent to then actually start to collect the hydrothermal vent fluid. We fly then to the next location where we're going to be actually sampling a black smoker. So you can see there, we've raised the IGT with the manipulator to collect those fluids. That process usually takes about 25 minutes to fill. And then we're up and off and moving to the 3rd location. Now, this one we got a little lost. So we had to sit down for a little bit and call the surface on the hydrophone and just say, remember when you told us to find that really white spot, but it was up and around this fallen rock? That was what our directions were. We had to get better directions on how to get into it, because these structures are huge that you're navigating through and around. So we finally got some better instructions, and we're able to find that small little mat with the broken rock and collect those non-colonized. So there's no tube worms in this area to collect that vent fluid using our titanium wand. The very last site was, I think, the coolest. And so once we've collected these pieces, we picked up and we went all the way across to another site called Dante, which is about a 15-meter hydrothermal vent. And so the transit time in reality between these sites is usually about, in this case, this one was about 35 minutes to get to the next location. And so this point, we had a rock on my side that was, or part of the vent that was quite large, that I was helping Kaitlin to make sure that we didn't hit, because we were really close and we had to wedge ourselves into this area, perch the basket. And then one of the things that you can see them doing is using the wand to probe in different locations. Now, why on earth are we doing that? We're trying to get an idea of the temperature at the different locations. And also we're using to also look at how oxidative, or how the ability to donate or receive electrons for these microbes. And that was time. We dumped our last 400 pounds of weight that we had on either, we have 400 pounds on either side, or 200, we have 2 sets of 200 on either side, and we surfaced. And it took us about 50 minutes or so to surface. The snorkelers then snorkel on out to us. And they will get into the hatch, get the comm system working and start to secure a tow line for us to then be dragged back to the parent ship and hoisted back on board. And so kind of like a 3-minute, just quick version of getting us through a dive. And so this is the team. They're throwing that tow line to the snorkelers. You can see Rick right here. He is talking to the ship, looking at the position of the ship relative to the submersible so that we can hoist it back on. And the team guiding the submersible back to the parent ship or Atlantis. And then they have to bail overboard, and the safety boat will then pick them up. So after the dive, you do have a little celebration, especially if it's your very first dive. You get doused with key water. You used to get doused with a whole bucket of ice water, and you get a certificate for the dive. And then the hard part begins because you have to write. I brought it with me actually. You have to write like a 4-page dive report on every single thing that you did on the dive. So the science part then kicks in after that. Um, and so, oops, sorry. And so that was everything I had for you. I wanted to share some bits and pieces, but I also wanted to hear from you if you had any questions for me. So I'll open it up at this stage to questions that you might have.
That's great. Thank you so much. This is so interesting, and it definitely feels like we virtually got to go on a little dive with you. So that was very cool. So please put questions in the chat. We do have like a couple questions already, Kaitlin. So the first question from Lisa is, do you preserve the captured organisms, and how can you preserve the microbial samples once they're at the surface as well?
Yeah. And so great question. So the microbes, the fluid goes right into an incubation. We can delay the incubation slightly by putting them in the refrigerator at pressure. But once the incubation starts, we haven't that's it. That sample is done for analysis in terms of looking at the microbes there. But then some of the other water that we sampled, so there is some water that we sampled not at pressure, and they were also run through a filter. And that's going to help us to extract the DNA of the microbes that are there, and those filters can be preserved. The tube worms, really, we were interested in just the slime, but some of the teams did preserve some of the tube worms, but almost all the tube worms went back overboard at the end once we had extracted the slime. So the main thing we were preserving for later was the filters for DNA for the microbes. But the rest of the incubations happened, about 50% of them happened on board, and the rest will happen back at Lehigh University.
A similar question, well, on the same line rather, is so you were out at sea for a while. How many dives did Alvin did, and were they all focused on the same scientific investigations?
Yeah, that's a great question. So we had only 9, we had 15 Alvin dives planned because of weather. We got out 9 times, which was still pretty good. But we did have some rough weather in between that grounded Alvin. We were staying within the size of probably your hometown city. And so we were very, very, and that was what was unique about this cruise. It was very highly focused on microbes within gardens and microbes with not in gardens and only a meter off the surface. And so that was, it's not, we had an astrobiologist. And so she was really interested in looking at how these microbes compare to microbes on other planets. We had a geologist, we had some sedimentologists, and then we had our fluid chemists. But we didn't have this huge multidisciplinary team. This was a pretty singular question. So we spent probably in total about 50 hours on the bottom. And I saw another question come through. How deep were you? I forgot to mention that. That's a good question. Most of our sites were all around 2,000 to 2,500 meters.
And one of our groups, it seems like needs more clarification about why is the water so warm down there when you're down so deep? And I think they would expect it to be cold.
Yeah. So you're absolutely right that the water is cold. Like when it's like 4 degrees C, like you're like when there's some padding inside the sphere of the titanium, but the titanium gets quite cold. So you can move it and put your hand in there and it's freezing ice cube cold. But you have this weird dynamic where you have magma, really active magma sites very close nearby, that all this magma is kind of circulating in these areas. And so you do have this dynamic where really hot meets really cold. And that's really the reason you get this precipitation, is because you have this hot fluid shooting out like a geyser, hitting the cold water and precipitating out and making these castles. They're chimneys, but they're kind of like castle-like.
Yeah. And one of our groups wants to know more about coming back up. So, do you come all the way to the surface and then you get out, or do you have to swim up? Like, how does all of that work?
Yeah, great. So the snorkelers are swimming, but we are all the way hoisted back onto the base on the ship on the back deck before we can climb on out. So it probably, from the time we get to the surface to the time our feet actually climb out, because you don't wear shoes, you're in socks, is about 45 minutes. So the snorkelers are in the water with the vehicle, but you're never in the water. Well, you are, but you're not physically touching the water.
Gotcha. One of our other groups wants to know about the weights. So, what were the weights that you guys dropped, and do we leave them there? What's the
Yeah.
story with that?
That's a really great question. We do leave them there. They are lead, and they are not biodegradable. We have to get a special permit to be able to leave Alvin's weights there. So you drop one set when you get down to become neutrally buoyant, and then to come to the surface, you drop another set. And that makes you positively buoyant to the surface. So it is bio waste. I mean, not bio waste. It is waste that you are leaving on the bottom. But in all instances, when you have to leave equipment on the bottom like that, you have to have a permit to be able to do so. But it'd be nice to find like lead biodegradable. I mean, I don't know how you do it, but
Yeah,
sand, giant sandbags. The thing is, it has to be streamlined. So the weights fit really tiny along the edges of Alvin. I can go back and find a better picture, but yeah, you could use like sandbags if you could design it correctly.
yeah. It sounds like a good engineering design problem for some students.
Hmm.
One of our groups wants to know if water could potentially get inside the Alvin.
Great question. So one of the things that we do have water in Alvin, because you actually get a little condensation inside the windows because of the gases. So it kind of is like a little bit of a drip on the inside of the window, and that's just the gas exchange and the temperature difference. But that hatch is sealed. And if you were getting any water, it would your weakest points of Alvin are your windows and the hatch seal. And if you were getting any leaks there, that would trigger a call to the surface, and you would likely enact a plan to surface. You're always checking gases. You're always checking battery life. Those are like the two main things you're checking. But condensation, like large drips, would be another red flag.
When you say gases, do you mean like oxygen and carbon dioxide?
Correct. Yes. Sorry.
Okay.
Yeah.
No, that makes sense. And then while you guys were up on the surface, I guess, did you see any sharks or whales?
We did. We saw some small blue sharks. They're probably like two or three. They weren't very big. They were juveniles. And we did see, I'm just trying to remember if it was a fin whale that we saw, but we only spotted two whales, tons of dolphins bow riding on the ship. But the biggest thing we saw when we were down there is really those spider crabs, because they're pretty, but we didn't see any big bigger creatures at depth on our way down or our way up.
And what is your favorite underwater animal?
Ooh, so one of the things that I did see, I don't know if the sound is probably going to come through, but I did see a flapjack octopus. Oops, sorry. Let me just skip to it. And it was floating. We were in transit from one location to another, and it was only about, I want to say it was like 6 to 8 inches across. I did a sketch of it in my book. But this is what a flapjack octopus looks like. I didn't get a chance to get any video of it. But this is from the same
I wonder,
location of a
though,
flapjack
if
octopus,
you'll notice
so at
like
the
their
Endeavour.
tentacles
And
are
it
a
was the
lot
coolest
more
thing that I
their
saw on my
arms, I
dive.
guess,
It
are a
was
lot
bright
have like a lot more
orange,
webbing between them
and
compared to
it
like
was
other
pretty cool.
octopods we've seen.
Mhm.
That is awesome. Any other questions? Well, I have another question. You mentioned that the pilot was only 28 years old. So what's the career path to like become a pilot and get to drive a submersible?
Yeah. So, Kaitlin, the training pathway, they are studying mechanical engineering currently. And so a lot of them do come from an engineering background. We had five pilots on board, and they all had but we also had two mate interns. I don't know for some of you that are maybe in the room, you know about the Marine Advanced Technology Education internship, but it's a really great way to get experience on research vessels at a university level. And so we had two kind of assistant engineers in the MATE program that were also part of the engineering team for Alvin. And the pathway is pretty intense in terms of you're actually become a pilot within the Navy system. And so there's certain exams that have to be passed. And then there's a certain number of training and testing dives to be able to get your certification to get all the way to 6,500 meters. And so because you can get certified to shallower depths first, obviously, and then you have to do a certain number of dives with a trained pilot. But I believe that there's only, don't quote me on it, but I know I'm pretty sure there's only 47 pilots ever of Alvin. So it's a pretty difficult certification to get. So to be 28 and get it is pretty cool.
That is really cool.
First female as well to ever.
That's great.
Yeah.
So if some of our other folks want to know about how do you get to go on Alvin and what are the requirements before you can do something like that?
Yeah, so I would say basically at the beginning of the cruise, if you're on an Atlantic cruise with Alvin, they will ask the whole science party who would like to dive. And so I just at first I was really nervous, actually. I'm not gonna lie. I was like, do I really want to go to 2,000 meters? But I decided I put my hat in the ring and put my hand up and I made it on the very last dive. So I would just say like at this case is getting out on research, having research experience on ships, and have a comfort level with being in the water, and operating technology, and then also just being able to say yes. And so part of it was being able to be part of the science party for Alvin. And I think the best way for a lot of you that are your age, is to look into the MATE program in university to get some experience on big ships.
Yeah, there are definitely lots of internships out there for, starting. You don't always have to get to start with a big ship, but you might be able to start some other research or engineering kinds of opportunities like in high school. And then programs like the MATE program, which I did put in the chat, a link to it for college internships, are really amazing if this is something you're interested in. It's all about marine technology and the engineering and the science, they all really work together because none of this work would be possible without the other branches of STEM. So it's super important.
And I,
Um,
I will say a lot of the engineers there was 11 on the engineering team for Alvin, and most of them started by piloting ROVs. So you could build your own ROV tomorrow out of PVC pipe and start your piloting practice. So they mostly started piloting things like Jason and smaller ROVs for inspection cameras and things like that, and then progressed their way to working on a submersible.
Totally. And so if you're in school and your school, if you're interested in this, like a good start would be to join like a robotics team, or something like that. And so a lot of the robotics teams then join into things like ROV competitions and that kind of work. So very similar. The link is working for me, Lisa. I don't know what's
Um,
happening.
I was going to say for my teachers, well, actually anybody who's interested, I'm going to share with Dr. Marrero a 5-minute internal tour of Alvin from one of the pilots. I didn't have time for the call today as I'll even a little over anyway. But it is a 5-minute tour where Bruce Strickshot, one of Alvin's pilots, walks you through the entire internal of the sphere. So I will share that and a couple of other assets in case it might be interesting to some of your students.
Very cool. Thank you. And I see one more question. I think we'll close up after that. Was there ever a major malfunction on Alvin? I know Alvin's
Yes.
been going for a long time now.
Yeah, so Alvin's been in operation for over 60 years. It's never had a major emergency. But so to give you an example of the overhaul that it has to have every 5 years, as soon as I stepped off Alvin, they immediately started to disassemble it to ship it back to Woods Hole. And it actually drove across the country on a truck all the way from Oregon to Massachusetts. And right now it is completely in pieces and is being inspected and rebuilt and won't start testing again here. It's actually going to be testing here in Bermuda in June. So that's how long kind of this like service piece of, and that's what helps keep Alvin's safety record. There is an instance where it got lodged in the fissure, and now I can see it because when you're down there, these crevices look small, and I can see you not seeing it, and that you have something overhead, and it got lodged. And it eventually was able to break free of the fissure, but that was an emergency call to the surface. It also did at one point a swordfish got lodged in it, and they had to bring the swordfish to the surface. And so those are the two. The only other time is there was a fail on the gases, and they did have to come up with their oxygen masks on, but the gas mix was still fine the whole way. But those are the three events that the pilots described to me.
Good to know there are so many safety measures in place. So that's a good thing. Well, thank you so much, Kaitlin. This was wonderful. I think we all learned a lot, and thanks for answering so many questions from our students and our members of the public today. Thank you, everyone, for joining. We're so glad to have you, and hope to see you on our next event. Thanks, everybody.
Thanks for having me, everybody.